Now, the first part is the sun. If we have time, I'll do the second part. But the thing I wanted to emphasize is that it's a very simple equipment. I mean, the camera, an ordinary DSLR, that's it. That's the most sophisticated equipment, apart from the computer that do the processing on. So anyway, looking at the sun, just a reminder, not really necessary really, but when you look at it in white light, you're looking at this photosphere. We call it this bit here. With hydrogen alpha, you tend to be looking above the photosphere. You're looking at the plasma directly above it here, which is why it looks like this. And then way above the top is the corona and all this thing is going on. Now, this is a sort of thing that the specialist NASA satellites and things report. There's always a lot going on there. But it's just this bit, the photosphere, looking at today. So this is just to remind you that this is what we're going to see. And this with the hydrogen alpha telescope, although I'm not sure it's quite that color, but that's where we would be. So this is some stuff off the web. What you're going to see on the photosphere, you'll see sunspots, if you're lucky, with this sort of dark inner bit and then a sort of grey periphery. You see these paler patches which are around about, particularly easy to see near the edges of the sun, and they're always around sunspots. And then there's this texture, the surface there, which is to do with granulation, although it's not quite as straightforward as that, despite what some people might say. So now if you have the seeing conditions and the magnification, I suppose, you zoom into a sunspot and it will tend to look like this. The dark bit, fine, but there are this sort of penumbra, this medium, not so dark part, has this sort of fibrous consistency, and then around it are all these little boxes. Now these are granules. These are the proper solar granules. They say, the size of Texas, so that's about 800 to 1,000 miles across. They hang around for sort of 10 minutes before they collapse and another one takes its place. So it's constantly boiling, constantly turning over. And really, if the conditions are right, that's within amateur range. You should be able to see that, but usually conditions aren't. So this is just to remind you, there's the texture at the bottom. These are the granules. But zooming out a bit, you get this sort of, I would call it a texture, and then way out, well, what can you see? So another refinement, which I have used but don't really like it, if you are looking at the sun with white light, you can use one of these continuum filters this is from Barda, and it's a green filter, but it's rather special. It's a very narrow bandwidth. I think it's only 10 nanometers. It's right in the green. The idea being that your eye is most sensitive to green, and so you'll pick up detail a bit more. Visually, I think maybe it depends on conditions really, but photographically, I haven't found it any use at all because I want more light. But anyway, there we go. So how can you look at white light sun? Well, either you can do the old-fashioned projection method, like here. That's fair enough, but hardly anyone seems to do that anymore. I certainly never bothered with it. Or you can put a filter across the aperture like this. This is the relatively cheap Barda, again, Barda solar filter paper, not paper, a film. You can buy it as an A4 sheet and cut it to fit, or you can buy other ones. But this is really very good, very cheap, quite reliable. Or down at the bottom here, the so-called Herschel wedge. Now, these have come down in price in the last 5-6 years. They used to be prohibitively expensive for amateurs, but I bought mine about 5 years ago in a sale, quite a good price, and I actually didn't use it that much for quite a while because the sun wasn't doing very much. But there we go. Now, if this works, oh, it's not going to work. Well, this is a real close-up. It might even be a simulation, but the idea is that as you run this, stop working, you can see these granules sort of growing and being replaced and so on over a time of about 10 minutes for each one. But there we go. Now this picture, this is solar granules taken really well. Now this was in the April edition of the EA journal. This young lady here took this picture. She got a prize for it, and it is remarkably good for a ground-based instrument. But it was taken with an 11-inch telescope, which is presumably this one at the back, and through some Barda filter screen. But that's not the whole story. First of all, she had to get up very early in the morning because with the sun, the seeing really, for most astronomy, you wait till the thing is high up in the sky to avoid looking through too much air. But with the sun, if you wait too long, the air is warming up during the day and it gets more unstable. So there's a kind of period early on in the morning, not too early, but fairly early, where the compromise is you get the best seeing for the sun. So she did that, and she also used not the visual ordinary Barda film, but the old photographic one, which you can't get anymore, which is a bit thinner, not really safe to look through, but does mean you can have very short exposures. And she managed to get hold of some on the grapevine, and this marvelous picture, she got a prize for it. So good for her. It's quite an interesting article in that time. But anyway, what have I been doing? Well, this is my refractor. Herschel wedges can only be used with a refractor because you're not doing anything at the top. All the sunlight's coming through, and then it's going to go into here, and I'll sort it out in a moment. But you can't really have mirrors and things here because the heat is the rays are too concentrated, and you're asking for trouble. So you really can only use a refractor. Though what it does, the light comes in here, the strong sunlight, and most of it doesn't go through, doesn't get reflected. Most of it just goes through to this heat sink back, just the hot plate. And a small proportion, now they say about 5% here, is reflected off for you to look at. But actually it's not. There's a filter, there are more filters in here to cut it down even further, and you shouldn't be taking those out. And then finally, as the light emerges here, it's actually plane polarized because of this. That's what you get off of a flat surface here. And so you can vary the intensity of what you're looking at by twisting a polarized filter. You have it screwed into your eyepiece. You can rotate the eyepiece and you can then darken it up a bit if you want to look around a sunspot or brighten it up. I've not done that with the photography because I'm after as much light as I can get. Anyway, that's the telescope, and look, it's on an ordinary Altaz mount with some slow motions, no lining up clock drivers or anything, none of that. It's not a sunny day, but this was the day of these partial solar eclipse in early June, so just shooting through the occasional gap in the clouds. What I do is, when the sun's shining, I actually take the caps off the finder scope here, hold my hand to the bottom, and I can just see the sun cast on my hand. I just move the telescope till that's all right, and then put the caps back on. Focus the telescope on as best I can on the sunspot. You need a sunspot really to focus on, and then hold. I take my camera, which is one of these, and hold it up to the eyepiece. And I have the camera focused on infinity, and I tried various settings, but I'll come to it in a minute. And this is an early attempt a couple of years ago. I didn't do much about it, and I picked up this. I thought, oh, vaguely I can see the texture, and you can see this light areas around the sunspot. That's all right. I did a little bit more. This is again around that a couple of summers ago. This bottom one here is actually with a mobile phone, according to my records. What you can see here, though, you see these little dark dots here, that's sensor dirt. That's dirt on the sensor, the camera sensor, which is such a pain. You can see it here, and I've got quite a few examples of that. It's a problem. No, but this is a better eclipse back in June, start of June. So I took this here. I've actually darkened it up and processed it to bring out the texture. So there's a lot of limb darkening on the sun here, far more than perhaps practical. But there's a bit of action going down here with some an active group. There are, although it's mixed up with dirt and dust, there is a sunspot group there. This is I don't know when this was, sometime later. The nice little sunspot group coming through, another one up there, and again you get this texturing. Now, going on, I took some more, get some more sunspots. Here we are. This is with a more powerful eyepiece in, and I'm shooting at around 100, about 800th of a second. So I'm hand holding it and just take loads and loads of snaps, snap, snap, snap. And then when you go through them afterwards, one or two are sharper than the others, and those are the ones you pick out and work on. Sensor dirt, yes, you can see the odd dots here, and you might be able to see the odd blob. That will be a bit more evident in a moment. Like here, now this is actually filthy with sensor dirt. Quite a good or bad example of it. But you also might be able to make out, depending on the screen contrast, rather blobby things, which are actually dirt and dust in the optics of the lens of the camera. They don't focus at all. They just come through as blobs. This was an old kit lens, and it was ancient. I've dropped it in mud. The internal surfaces are never going to be clean, and I just can't get rid of these blobs. They're worse on some of the other shots. Now, one of the things that's handy with this is you can take pictures very, very quick, even if you've only got a few minutes between the clouds. And so these are sequences. I'm still learning how to match them up. Day by day of a given sunspot group. So the one across the top, these are daily intervals. They vary a bit quality because it's probably shooting through cloud once or twice. But again, but you can see these blobby things in the lens dirt, very obviously on some of these. But this sunspot seems to shrink a bit, but then grow a partner. So that's what happened over the course of those 5 days. This middle one, or middle pair, these were taken, I think, late one afternoon and early the next day. So I think they're about 17 hours apart. And it's just very subtle changes in the penumbra here that are really obvious. The bottom one, I'll put some of these on the chat group before. This is 5 days in a row, and I think I've denoised the bottom one and left the top one. That's the only difference. But again, there's this, I'm beginning to get the hang of putting these strips together now. And the obvious developments, these little bits flare up and then fade away, which seems to be a pattern. Now this one down the side, this is my better resolution ones. Again, I think it goes top to bottom. So there you go, and it's growing and then developing, and then I think the weather closes in. So these are not bad really, and they're really dead easy. I'm just hand holding, snap, snap, and then have a look, process that with Infinity, usually do a lot of stretching and so on the processing. But fair enough, I'm not too displeased with that. Now, the main issue is, can you get more detail? Well, no, because it's hard enough to focus on the little sunspot as it is. But also, there may not be anything to focus on, in the sense that the seeing itself may be the limit. So you're limited by the conditions rather than your instrument. But there it is. Now, this is I've enhanced this one up a bit, just a demonstration really. These dots here are sensor dirt, and the little halos around them are artifacts from the unsharp masking I've done. I've enhanced the resolution a bit, and it brings this sort of thing out. So it's just a thing. Now this is where things got better. I took this, I think, at the beginning of this month, and the conditions were favourable. The sky, the seeing was really stable, and so I managed to get some of these pictures, and now the fibrous like nature of the penumbra is beginning to come through. The umbra, the dark, is actually at two slightly different tones, although I'm struggling to bring those out. And you can begin to see, well, is this granulation behind it? Well, it is, but it's just a little bit blurred. It's not ISO noise. It's easy to demonstrate that, simply because you can change the ISO setting on the camera and it's reproducible up to a point. This is the same sunspot the next day, I think. The conditions were even better, and yeah, that's looking okay. I mean, it seems to be developing these complex things which will then fade away probably quite quickly. So this is quite promising. Very easy to do, easy to collect day after day, build little movies and things. But how far can you go with it? Whoops. Well, this is the whole disk of the sun. Now this is with ISO at 100. That's as low as the camera will go. I think it's about 2,000ths of a second as well. Exposure, something very short. Now, again, I fiddled with the gamma function actually to make this sort of rather awful dark limb and slightly brighter middle bit. But the middle bit, if you actually zoom into it, it looks like this. So there is this texture. It's definitely there. It's not an artifact. And the ISO at 100, well, you can't go any lower. But what of it? Well, you see it here. This is a sunspot from a few weeks ago, and I've actually over enhanced it, so the umbra is really dark. But you can see, you know, there's something going on around here. It's not quite. It's not quite the little cells of granulation that you might. It's not quite that. It could be in there, but it's a bit more than that. Now, what it turns out to be is something called supergranulation, which doesn't receive much attention, but essentially the granulation here, with those cells are sort of 1,000 miles across, but they actually are in larger kind of bodies, which are really 30 times bigger. Now these is supergranules. They're rather vague, and this contour map, I think this is showing a Doppler shift. I think they do actually seem to move around sideways. I think they were thinking or whatever. But they last about a day and a half. One of these. They're not really a cell as such, but they are. Well, maybe they are. They are a structure. Now they're not. It's not fully understood, but I put in supergranulation into the BAA website as a search option, and there was nothing on there at all. So no one really pays any attention to this. But I do think a lot of images, some people confuse themselves by thinking they see this and that it's really that at the bottom. So this is supergranulation. I pinched this off of some observatory website. I'm not sure even what wavelength that is, but it's the same sort of thing, this texture, which is exactly what I can see. And here it is again, but you can see here I'm getting these little blobs coming up. Now what I've done to get this, I've used a different lens, a 50mm prime lens, and a new one, so it was a lot cleaner. And I can open up its aperture to 1.8, which is enormous. But when I do that, I seem to start getting this blobbiness. I'll show you a bit more of that in a moment. So we'll just go through to here. Now here we go. Look at all these little blobs. They look awfully as if they ought to be something. Now these two shots were taken a few seconds apart as I'm just clicking away at the camera as the sunspot moves, because the telescope isn't tracking. You get a series of these pictures. The curvature here isn't the limb of the sun, it's just the edge of the eyepiece or the field of view. And here the green is the grass, because I'm not actually close enough to the eyepiece. Here is again processed up a bit more, and you can see this sort of thing here going on. It looks like you've got, as if the supergranulation is showing itself up as well, more obviously, I think, but I don't think it is. If you take, this is a particular example where I'm messing around for a particular reason, and I'm pulling the lens quite back from the camera, letting a lot of other light come in, and that's ridiculous. That can't be right. And these two pictures were taken, again, just a few seconds apart. And this is a GIF, there we go. These, as we move between these two images, if these dots were really on the sun, they'd move with the spot, but they don't, not really. There seems, it's something to do with multiple reflections, because there's a lot of optical surfaces here. I really want to know exactly what that is in order to stop it happening. But as you can see, look, there are spots around the sun, the sunspot here, and they're not there a few seconds later when everything's moved slightly. So I'm still looking into that. And here again, this is another one. This is, I've taken these pictures again a few seconds apart, and I've just put them into a GIF, so they just go from one to one. And if you look at any of these blobs on the background here, they don't really move with the spot. They just don't. So I'm going to think about this a bit more, because if it was real, it'd be superb, but I'm sure it isn't. It's some kind of artifact, and I'd like to know what it is, and then I can stop it. Now, just finally for this, well, the sun here, these images here were taken, they're single exposures, both of them. They're not processed. I haven't put anything in Photoshop or anything like that. I actually use a very wide aperture, which I think is a mistake, because it means too much peripheral stuff gets in. And I don't know how come this bit of fern is in focus when the camera is focused at infinity. But nonetheless, there it is. So you have this incongruous combinations. There's the sun, 93 million miles away, these sunspots, the size of the Earth, and there's my garden in the same picture. So probably as a combination of components, it's probably unique. But no astronomical interest at all. But I think as some sort of artistic statement or contrast, it's got something going for it. So there we are with the sun. You can take pictures with the way I've done, really just hand holding and snapping, but there seems to be other artifacts creeping in, and I'd like to sort them out before I make any claims of anything. So that's the solar thing. Shall I push on with the ISS, Rod, I think? Or anyone who's not muted?
It's up to you, John. I mean, I'm happy. I don't know how other people feel. It's 20 to 10.
Yeah, crack on.
Yeah.
I'm very impressed, by the way.
Well, you ain't seen nothing yet, so you can see this next bit.
Right. Okay.
Right.
Don't take that one then, John.
No, but this is to remind you about the International Space Station, the central structure of it. This long spar here with the solar panels, which can all rotate in different directions. And in fact, around this spindle, this spar is like a spindle. They can rotate so they're in the same plane as the main modules here, or as they are here, perpendicular. The American part of the station is this rear bit here where the Dragons usually attach, and the other end is the Russian part where the Soyuz and Progress modules Doc, these panels here, these are radiators, and they show up a lot, but it depends on how they're oriented. So if they're like this, face on, yes, you'll see them. But if they're put edge on, and they're not, it's three components, so they each go, when they go edge on, they go side by side still. You don't see them so much. But now this is somebody seriously doing it. This website here is well worth a look if you're interested. And Dobsonian is a superb thing to use because it's easy to track. You follow the space station through the finder scope, try and keep it in the center, and he's got a planetary camera on this end of this lead here, and his laptop is tucked away down there. So that's a serious way of doing it. And the pictures, well, this sort of thing here, although, and better than that, I should say. But mine aren't. Mine, I'm just doing this with a 6-inch Matsukov, the old camera again, same one as before. I have to get on my knees and look through this finder scope and try and keep the space station on the crosshairs as it sweeps across the sky whilst filming it, whilst in video mode filming. And it's quite hard actually when the ISS is very high. Although it's as close as it gets, it's harder then to actually image. So one thing we had this last week, the Dragon SpaceX thing was attached at this end originally, but then on the 21st they moved it around the corner to here for some reason, I don't know. So this picture here I took after they'd moved it, and it was the best reorienting I could do. But this bit here is there, and there's no Dragon module, it's gone. Whereas earlier, this is a different orientation, but this picture down here, that's the Dragon there. But it's gone. I haven't got two comparable, but that was a change that you could quite readily pick out. These are images from earlier, I think last year actually, and in March. So yeah, there's the radiator panel showing up. That's all right. And a bit of detail here. Blown up a bit too much actually, I think. But anyway, this time round, what have I got? Well, one of the things is they've got new solar panels which have been unfurled next to one end, the arrays on one end of the central spar, and they're small at a slight angle. So this video image here was taken by somebody, I think in New York, with a telescope that, I think when I looked it up, it was £8,000 for the optical tube alone. Well, it was much bigger than mine and much better camera. But nonetheless, if you look at my image, and then there's a bit of diagonal thing there and there, those are the new arrays, just about showing up. They're not terribly well illuminated, but that's definitely real, and there it is. So that's I can see that. Also, this is a little bit of a GIF from that a night before, I think, when no, a few nights later. I'm actually going through cloud here, which is why the image is so awful. Clouds are bad news because obviously you get less light, but the air is often turbulent around a cloud, so the seeing is even worse. I mean, any other kind of astronomy, you haven't bothered in the first place. But if you are shooting through cloud, very often it's pretty ropey. And this glint here is off that new array because we've never seen this before, and it's just the way they're catching it. And again, there was a spaceweather.com had a nice, much nicer picture, but that was mine. This is again, I've turned it around, but the Russian part of the thing is here. And these, I'm not sure what these are. These could be, I'm not sure. I think that's a Progress or Soyuz. It's in the right kind of place, but they should be up and down a bit more. I'm not convinced I know what these bits are, so I'll look into that. This is one of the better ones of the day. The radiators are showing up nicely. don't know what that is, but the American module is there, and there's the Dragon, because this is before they moved it. This is another series, I think actually from the same pass. Now I did put on the chat line, I did actually combine two of these to give a stereo view, which actually worked quite well. You could really get a sense for what was going on the spar, better than with these single shots, because they are a bit limited. Anyway, there we go. These are higher resolution. Well, supposedly I used a more higher power, but the image was a lot dimmer. And in the end, I wasn't quite sure if it was worth it. You can begin to see more detail, but really, most of the time, the conditions weren't favourable. So, and you really are limited by the conditions in a way. Well, you really feel it. Now, this is just, I've done a few GIFs. Now, this one up here is simply, I think it was, is it from this time around? It's from during a pass and how the angle orientation changes. This one over here on the right, just to show sometimes as the space station recedes from you, it seems to flash or get a bit brighter. And this shows you why, because as it goes away, sometimes here, the panels, the solar panels, particularly what turns out to be the lower set, catch the light and you get this bright flash. There we go, like that. And this one's similar at the bottom. It's very bright flash late on in the pass, and that's what's going on. It's just the way the panels are oriented, about which I don't know quite enough. These are just some GIFs I put together. I did put these on the chat line some time ago. This is just trying to give you a 3D feel for the station. There's the Dragon spaceship there, nice bright and white. It does show up really well. This one here, on the left, as the station goes by, it's simply, I'm not sure what I'm showing. Oh yeah, it's just the fact you can see a few things about it. Yeah, it's just the orientation changing as it goes by. And then just finally, this is, well, not quite, but this is one pass as it goes ahead, and this is the 1 hour and a half later. Try to match them up. And what you might notice is the solar panels at a different angle. Said they could rotate around this spindle. And I've tried to show that in a GIF. So this GIF here, which I haven't managed to scale them exactly the same, because one was a bit further away, trying to show the fact that the panels are rotating a little bit, one orbit to the next. Anyway, that's it. So just to say, well, that was what it was taken with, not with that finder scope, that kind of thing. And the sun stuff was done with that. Just very quickly, because some people are new here, you can do things other than the space station. These are satellites, big ones, and lucky to catch. So you're not quite sure what's going on with these, what you're actually seeing at all. This one here was actually, when I matched it up, was meant to be this Russian thing. Yeah, I suppose you could make that out. This one, the right one here, that's a big satellite, and it's an American spy satellite. We don't know what it looks like because it's classified. So heaven knows if this resembles anything at all real, because they're not going to tell us. But it's a big, substantial thing, optically as powerful as the Hubble. Here's a Russian thing, which was that, and you can see the resemblance. That's not too bad. And comparing it to the space station, I've made the satellite twice as big, but it's about the same height as the space station, more or less. So yeah, if you halve its size, it's about the right size relative to that. I don't know how big that is. And then finally, I think almost finally, these are what you sometimes get in orbit are the rocket boosters that are left behind once the satellite has been released. And the boosters are often left up there, and they can be tumbling depending on what happened as the satellite was released. Sometimes it's a simple tumble around one axis, but sometimes it's more complex around two axes. There's not much to say other than you can see a rocket tumbling. But it's not very often you see things change that quickly. And that's it. That's my, where are we? Stop sharing. Here we go. So that's my quick look at the space station and the sun. So a lot of you have got better telescopes and cameras than I have, so do something with them. Have a go with these.
Thanks very much, John. Absolutely excellent. Incredibly impressed by what you seem to be able to achieve. I don't suppose you've thought of using a right-angled finder?
Well, no, because sometimes you lose track of the station and you need then to look along the finder to see where it's gone to. And you wouldn't be able to do that with a right-angled one. You'd have to, 'cause sometimes you lose it completely, and you need to be able to quickly line it up again. Otherwise, I'd be looking at right angles and have to get down on my knees and look along the barrel of the telescope. Ideally, you want two finders, but I haven't got another socket for it.
John, you mentioned several times during your talk about the ISS that the SpaceX module appeared to be relocated. How do they do that then? Do they just undock and then dock somewhere else? It's not that it's been down to Earth and come back again.
No. They actually deliberately they took it off and just moved it. So undocked it and moved it on. They did it with the Soyuz the other day as well. The Soyuz one was to free up a particular port they wanted to use for the next one.
All right.
And also gives them a bit of practice, a bit of checking over. I don't know if the Dragon was moved automatically or if somebody got in it. I'd have to look that up, but I was wondering where it had gone, and then I discovered they actually moved it.
Yeah. The other night, I was out looking at Peter Lyrie, as well as one or two other things, and the ISS did a pass, but I noticed there was another bright satellite just above it.
Yeah.
I can't remember which night it was, but I thought, well, what's that?
There was, I was told, I did find out afterwards that one night there was a Progress, one of these cargo vessels was actually following it in orbit and approaching it.
Oh, right.
But because I was looking at the station through the finder scope, and then I didn't step back and see if there's anything else. I'm rather annoyed myself because I could have maybe got that as well if I just looked around and realised it was happening.
No, just to rub salt in the wound, I actually did see it and I wondered what it was.
No, somebody got a picture of it. It
all right.
goes up quite well.
I saw it. Yeah.
I mean, what I think is a shame really for us is that I'd like to have a look at the Chinese space station, but it doesn't come this far north. The orbit's not inclined that much, so we're never going to see it. But I'd be interested to know what was going on with that. But I was thinking a proper planetary camera would be more sensitive, higher frame rate, and so on, which is what people use. But the trouble with that is the sensor size. Is something. I looked at one today, and it was 1/10 the area of the one I'm using at the moment. Well, that means because a lot of the frames where you're hand tracking miss the station, so only about a third, perhaps, the frames, if you're lucky, third, maybe a half if you're really lucky, of the frames have everything in them. Now, if I cut the sensor size right down, I would suspect that, I wouldn't have many frames to choose from, and it's whether that's worth it. I mean, other people seem to manage, but it's tricky. Hand guiding is really not easy, and so most of the frames are pretty empty.
Do the experts have something clever to follow the space station.
Yes, if you know,
Perhaps
they do. You can track it. If you've got a mount that can go quickly enough, and you've got the elements of the orbit, there are people who do that, who can track it with their fully controllable mounts.
just wondering if there's anything, it's like a slightly speeded up version of star guiding.
Well, you think of the slew speed of most telescopes. It's nowhere near what you need, but people have looked into it and upgraded the motors and things like that. But for the most part, people hand track.
John, just on a related subject, do you know if this Chinese space station, is it open to all astronauts throughout the world, or is it just Chinese?
Well, yes and no. The Chinese won't let anybody else on it.
Right.
They did open up, they did invite internationally people to submit experiments to run on it. So they will be taking up experiments, although the Americans supposedly tried to block that and also tried to blackmail the Italians into not taking up an offer of an experiment. So
That doesn't sound like Americans, does it?
Well, it's quite political.
Yeah.
Really.
John, thinking about your solar work, I'm sure you're using this afocal method, the camera lens, poking it against the eyepiece. Yeah, I'm sure you've thought of this. Is it not possible for you to attach your camera directly to the Herschel wedge and get a higher resolution?
Well, no, because the telescope, I'm stuck on an old telescope with an old mount that I can't really exchange, and I can't balance the thing if I have my DSLR on it, and neither can I get an adapter do some eyepiece projection.
You could try a counterweight at the top end of the telescope.
I have, but it's awfully faffy. I do think a lightweight planetary camera would be the thing to do, but then I've got to stop being so lazy and get my equatorial mount out and turn it on, which I've got. I've actually got a nice EQ5 with a upgrade on it. It's splendid, but it's just such a pain to drag it out and line it up in the daylight. As well.
Those little brown globule blobs that you were showing us in the last sequences, they do seem to be repeating patterns if you look carefully.
Yes, I suspect they are. Yeah.
So it would suggest that it's in the camera lens. If it's in the wedge, I would doubt it. Or if it was in the telescope lens, well, it's much too far away for them to be so clear. It may be imperfections on the surface of the lens elements, or even within the glass of the lens itself.
Well, it could be that the camera also, it's not, because I'm holding it, it's not actually perpendicular to the axis of the optical axis anymore. There may be a tilt on it, and you may be getting reflections and all sorts.
Well,
there's all sorts of possibilities, but yeah, I've only actually started seeing that when I've got this new lens, so I do suspect
it might be
that
that.
lens.
I think you're fighting against yourself with the afocal method. You're going to hit the old brick wall where you just can't get clearer pictures as long as you.
Oh no, but if you've only got a couple of minutes,
yeah.
It's fine. And I actually just wanted to see what I could do with it. No, it's never going to be better than doing it properly.
Sorry, I think Ray is possibly right with it. It reminds me when I used to take images of slides down a microscope with a camera. If you got tiny little particles on the condenser underneath the microscope, you got these little granule things on the final image that look just like the ones that you've got. Is it just bits of dust that you can't get rid of?
It could be. The lens I've got is the new lens I have is supposed to be pristine inside. It's not new. It is secondhand. No visible particles, but goodness knows. And you've got pollen out in the garden. You've got pollen going around and all sorts. And the eyepiece as well could be.
Yeah, you're dealing with very high magnifications. I've had eyepieces where there've been imperfections in the mass of the glass itself in the eyepiece, which do show up on high magnification, like these little blobby things, but you couldn't see them to the eye. Is it right?
Well, my Zoom eyepiece, which is a Vixen one, which I think would be excellent. I pull it out to the full longest focal length. You can see little bits of dirt. But as you go to shorter focal length, they blur away. But of course, it's still there. It's just they're not focused properly. So yes, it's and these my eyepieces, none of them are new. Knocking around, and I mean the one I used there, I think, I'm not sure which one it was. One of them I was using is best part of 30 years old.
Have you tried cleaning them with? We used to do this with microscope eyepieces when I was at work. Clean the lenses.
Oh, I clean the outside ones with all sorts. I've got some. I've got a lot of isopropanol, that kind of thing. But it's
the best thing to use is not that stuff, but very weak detergent and then a bit of alcohol. We had some guys from a microscope company come over and do a sort of short tutorial on this. The isopropanol and all that kind of stuff eventually wrecks the lenses. Well, microscopes anyway, and I'm assuming that telescope eyepieces are the same. So they suggested that to use very weak detergent to clean it and then let it dry and then just take all the residue off with a bit of ethanol.
I've wondered
the best way to do it. Yeah.
The isopropanol I've got is pure, but you sometimes wonder when you've wiped it away. It's still, when it dries up, you can see that there's something still left, which it never dissolved in the first place. But I'm reluctant to push stuff around because years ago I was cleaning the refractor's objective and enthusiastic using a lens cleaning liquid, and some of it seeped around the edge of the lens, got into the slightly between the two elements. It's barely visible, but I was very upset about that and very careful ever since. But yeah, there's plenty of scope. The more optical surfaces you've got, the more you're inviting. And I'm sure probably what 8, 9, 10 probably.
Yeah, there'll be one surface somewhere that's quite near to the focal plane.
Yeah.
Probably be a element you can't get anywhere near.